Okay, hey there. Welcome back for week 6 of me doing the weekly contest. Okay, we're right here. Let's just get straight into it. I think we just click on one of them, and there we go. Okay, sorry. Every single contest, I come at like the very last possible second. I was doing the daily challenge, and yes, I solved it, but not correctly, I believe, so I'll come back to that afterwards. But yeah, I stopped the recording like a minute and a half before the contest. I went to wash my hands and so on, and by the time I came back, it was just starting. So forgive me about that. Let's just get straight into this contest. Okay, so Q1. First of all, what is the orientation, right? So we have easy, medium, oh gosh, okay, easy, medium, hard, hard. Well, okay. You're given an array nums of n integers and two integers k and x. Okay. The x sum of an array is calculated by the following. Count the occurrences of all elements in the array. Keep only the oh my goodness. Okay. Let's look at an example, right? Okay. 1, 2, 3. Explanation. For the subarray, only elements 1 and 2 will be kept in the resulting subarray. Okay. Okay. Keep only the occurrences of the top x most frequent elements. Okay. If two elements have the same number of occurrences, the element with the bigger value is considered more frequent. What's the point of k? Okay. What's the point of k? Keep only the occurrences. What? Return an integer array answer of length n minus k plus 1. What? Answer of I? Oh, no, okay, this is an easy one, and I'm sure it's easy. It's just I'm having trouble understanding it. Also, what are the problems? Oh, so it's this and then part 2. Oh, goodness me. Okay. Oh, my goodness. Okay, you're given an array. Okay, the x sum of an array is calculated by the following procedures. So do I just call this problem from nums of I all the way out I plus k? Do I just do it for the first k elements? This is just so bizarre. Count the x sum of an array is calculated by this. Count the number of occurrences of all elements. Keep only the occurrences. Okay. Answer of I. Oh, so return all of them. Jeez. Okay. 1, 1, 2, 2, 3, 4. 1, 2, 3, 4, 5, 6. Oh, sorry, this is for the daily. Okay, this one. Then, okay. Okay, so ans is equal to this. Range. N is equal to length of nums. N minus k plus 1 plus or equal to find x sum helper of nums from I to I plus k minus 1. So this doesn't include plus k, so it would be like minus 1 and plus 1 to include. So yeah, let's just do that for now, just because I don't care about efficiency, not on the easy one. X sum helper, right? And here we'll do return ans, right? And so here we have a self and an array. So self dot, there we go, or answer dot append, whatever result this is, right? And now an array and an x. Length of r less than or equal to x returns. Yeah, there's a way to, like, you know, like sliding window this the hell out of this thing, right? Which is probably what's wanted for the hard. It's just here, let's just try to figure out a way to just actually do it, right? Even if it's dumb, right? I don't care about the copying and so on. But this problem is really annoyingly worded. If length of r is less than or equal to x, right? But it's like I'm just gonna be redoing work over and over and over and over. But for the easy one, I don't mind, right? Okay, so convert. So d is equal to this for in r. I can even do default dict of it, right? For num in r, d of num plus or equal to 1. There we go. And it's like, okay, we'll have a heap, min heap, this for num in d, heap q dot heap push into the min heap. We'll do, what do we want? Most frequent elements, the occurrence, so d of num. And then, for tiebreakers, with a bigger value, it's considered more frequent, so the num itself, right? So we want the biggest frequency and so on. And so right now we have a min heap, right? So we want the, yeah, okay. While length of min heap greater than x, heap q dot heap pop from the min heap, right? Sum of pair of 0 for pair in min heap. Something like this. Comma x min heap output is 6, 10, 12. That's not what I'm, what? Print min heap. This is the first time I actually spend time on the easy problem. This is bad. Bro, what? Frequency and the number, right? Frequency and the number. Print f string r equals. Bruh. There's no way I'm struggling on this easy, right? 1, 1, 2, 2, 3, 4. Okay. D of num plus or equal to 1. Print d. One to 2, 2 to 2, 3 to 1, 4 to 1. Right? So here 1 plus 1 plus 2 plus 2. Oh. So times pair of 1. Yeah, okay, 6, 10, 12. And then here it's going to be 11, 15, 15, 15. Okay, 12. Okay, this was like worded extremely poorly. I'm not even going to lie. Okay, hashtag print. There we go. So now, do we have an accepted solution? Okay, cool. That's all that matters. That is extremely poorly worded. I'm not even going to lie. Okay, kth largest oh my goodness. Okay, kth largest perfect subtree. Okay, what? Count the number of winning sequences. Oh, another Alice and Bob game. Jeez, okay. And then this boy again. Okay, but obviously something like this is way too slow, right? That's the idea. Right, and if I submit something like this, I just TLE. Yeah, okay, okay, 774 or 784, but I TLE. Okay, cool. So what are the difference in constraints there? So for this one, it was, yeah, nums of length is up to, okay. Yeah, and then here it's up to, yeah, 10 to the 5, 10 to, okay. So yeah, for the easy problems, just do what they tell you, right? Because like the constraints are always so small that it just make it easy for you. Okay, let's put myself here so I can read the problem. You're given the root of a binary, oh, it's a binary tree problem. Okay, I love binary tree problems. Root a binary tree, an integer k. Return an integer denoting the size of the kth largest perfect binary subtree, or -1 if it doesn't exist. It's a tree where all the leaves are on the same level, and every plant has... Whoa, okay. Right. Okay, if the original tree is a perfect binary tree, then all the subtrees are perfect binary trees, right? So it's like, here this is a perfect binary tree. The leaves are perfect binary trees, right? Yeah. Okay, the black nodes are perfect binary trees. Yeah. Leaves are perfect binary trees. Okay, so there's recursive nature to this. Okay, so it's perfect. Okay, so in the AVL tree, it's like perfect and so on, as long as the heights don't have a height balance difference more than 1 here, right? Here it'll be more than 0, right? Because okay, it'll compound, right? So it's like even if I don't have a node here, then this one is not perfect. And so first of all, you just check if two nodes are perfect or not. And then if they are, make sure that they have the same depth, right? Otherwise, you're not perfect. And anything above you is not perfect. And then it's like I can just do a in order search and just keep going linearly until I find the kth largest, right? Or something like that. Kth largest by what? What makes something large? Bruh, okay. The second largest is size 3. Oh, so there's a size 3 here, there's a size 3 here, there's a size 1 here, there's a size 1. Okay. There's going to be something to do with heights. So heights, a node is root of a perfect binary tree if and only if 1, 2 children are both perfect, height of both children are exactly same. Node values, none is perfect, right? Okay. I'd like to be able to extend this tree node, right? Yeah. I know how I'm gonna do this. And then we'll get to the hards. Okay. It's just a matter of implementation, right? It's just I don't want to be like, you know, slightly off track where it's like I do something wrong. Right. Is perfect. Or, you know, what I could do is like I have 2 dictionaries, right? One that maps nodes to heights, and one that maps nodes to is perfect, right? Underscore init self is perfect. All right. Self.populate root. Def populate self, comma root. If root in self.perfect. Turn. Otherwise, here we'll do none is true. Right, the none node is perfect. self.populate. Root.left. Self.populate. Root.right. Yeah, if it's in there, then just return. Self.isPerfect. Root.left. And self.isPerfect. Root.right. Is perfect equals this. Right, and here we'll do print self.isPerfect. And here we'll do print self.height. And here we'll return like 1. None will have a height of 0. We might even make it a height of -1. That's fine. Let's put myself here. Oh gosh. Let's just pretend they're unique here, right? 3, 5, they're not. Goodness me. Okay. This is too much, right? We'll do def in order. Self, root. If not root, return. Otherwise, we'll do self.inOrder root.left, self.inOrder root.right, and here we'll do print f-string root.val equals is perfect equals and height equals self.height of root self.isPerfect of root. Right, and here we'll do self.inOrder with root. Okay. We might as well do preorder. Right, so this one, so yeah, true and height of 1. True and height of 2, good. True and height of 1, good. 3, false with height of 3, good. 2, true with height of 1, good. 5, false with height of 1, 2, 3, 4, right? So good. Val 6, why do we have 6 is equal to true? Oh, it's this 6. Oh my goodness. Okay. Is equal to true with a height of 1. Yeah. Then this 5 is equal to true with a height of 2. Then this 8 is equal to true with a height of 1. And this 6. And based on the height, I actually know that the size, right? Because they're perfect trees. Oh my goodness. This is ingenious, right? Because it's like height of 1 is 1 node. Height of 2 is 3 nodes. Height of, it's always, it's 1 plus 2 plus 4. Right. I am a genius. Okay, I am a genius. Oh, well. Yeah, and I don't even care about speed, right? We just care about correctness. This is nice. This is very, very nice. Yeah, so 6 is false with a height of 3. 7 is true with a height of 1, ladies and gentlemen. That is what we care about. So self.populate works like a charm. That is very nice. Very nice. So valids. So perfects is equal to, for node in self dot is perfect, if self dot is perfect node, max heap, right? We want the kth largest. We can do a min heap, right? Once we have a k, and then there we go. Self dot is perfect node, and that way we just use the min heap implementation. So yeah, let's keep going. For node and self dot is perfect. If self dot is perfect node, then min heap dot append. What do we want to do? It's height, right? Self dot height of node. Not just height. Right, so essentially it's like, okay, 1 goes to 1, 2 goes to 3, 3 goes to 7, so 1, 2 to the 0. We'll do this. Height to node count is equal to this, right? And then we'll say def get node count from height, self comma height. If height in self dot height to node count, then we'll return self dot this of height, right? Otherwise we will do here we'll do a height of 1 is maps to 1, right? Here we'll do yeah, it's fine. We need to do sum for sum is equal to 0. In range height sub height in range 1 to height itself sum plus or equal to sum plus or equal to sub height actually okay and range height sum plus or equal to power of 2 to the I, right? So at first we'll add 1, then we'll add 2, so it's 3. So yeah, if it's 2, I to node count I equals sum self dot height to node count height is equal to sum. Turn. So now back here we'll do node count is equal to self dot from height of height. Here for now we can just ignore this guy. Right now I should focus on just getting a correct solution, not just speed, right? So node count is equal to that. So now, okay, height is equal to this guy. Node count is equal to that from height. Node count, right? Jesus. Okay. While length of min heap greater than k is k, right? Where I have access to k. Heap q dot heap pop from the min heap, right? And now return min heap at index 0. What am I pushing? Get node count. Why am I getting none values? Print height equals, node count equals, node count equals none. Oh, return sum, of course. Yeah, okay, so this is 3. Okay, prints become hashtag prints. Okay, so here we have 3. This is 7. Okay, we have 7. It's supposed to be -1. Here we return 0. Why do we return 0? Print length of min heap, comma k. Three and 3. Two, false. 4, true with height of 1. 1, false. 3, true with height of 1. I don't get it. Why is my length of the min heap 3? I count none in there? Yeah, I don't want to be counting none. I count none in all of them, right? I don't want a million penalties here. I still get 7, here I still get 3, here I get 1. If I print 2 and 3. Min heap is less than k. Right? Okay, I just gotta trust my abilities here, right? 3, 7. Okay, I just gotta trust my abilities. Frick. Okay. Shoot. I'm gonna get a penalty for that. That's a bummer. That's a huge bummer. Huge bummer. I should be more careful. It's just, I'm like, in a contest, you gotta be speedy, right? Okay. Hi, Dios. Is it less than or equal? That's what matters? Output is 1. Expected is not given. What? How do I get a wrong answer? Wait, they do give me the expected. Expected of 3. Ooh, so now I get 3. So maybe, okay, I do include none. Now this one I didn't return -1. And now I return -1. Here I return 3. Okay. Let's just be confident in my abilities here. Bro, are you serious? 2 penalties is what I'm gonna get. That hurts. That hurts a lot. I'm not even gonna lie. Am I doing this wrong? No, it's in the range height. Wait, I'm getting 3 for 5. What did I change? Okay, I add stuff. If it is not none. Okay, I should not be adding none anyways, right? Period. Right, I should just say like self dot is perfect of none equals false. Or del, this guy. Del self dot height of none. There we go. That's 3, that's 7, it's -1, that's 3, that's 3. Okay, is that just the problem? Oh my goodness, what am I doing? I'm just gonna get penalty after penalty after penalty. Am I not getting penalties? Like if I refresh here? Is there just no penalties today? Surely, right? What if I refreshed? Right? Okay, like if I duplicate this page. Maybe not. Okay, okay. A perfect binary tree is a tree where all the leaves are. Dude. Penalty time. None. Why is it none? I thought there were okay. Just why am I getting this wrong? Here the expected answer was what? Expected is 1. Okay, let's think carefully, right? Here it's like, surely I'm getting the right node count, right? It's like for height, right? If height is 1, I keep adding 2. Maybe the previous amount plus 1 is what I add, right? When I have 7, I add the previous plus 1, right? So if this is 7, 7 plus 8, right? 8 plus 9 is what, 17? That would make sense. This is 3, 7, -1, 1, 3. Bro, why? Why? Legit, why? Why? Yeah, I delete the nuns. Min heap is equal to this. For node and self that is perfect, if self that is perfect of the node, then we only consider the perfect ones, right? Hi. Their sizes in decreasing order are 3, 3, 1, 1, 1, 1, 1, 1, 1, 1. So here it's like if I print the min heap, bro, brother, three, 3, 1, 1, 1, 1, 1, 1. Print sorted min heap reverse equals true. I don't even care right now. 3, 3, 1, 1, 1, 1, 1, 1. This is 7, 3, 3, 1, 1, 1, 1. And k is equal to 1. Okay. Min heap dot sort. Reverse is equal to true. If k minus 1 is greater than length of min heap, return -1. Otherwise, we return min heap at index k minus 1, right? What does this give me? 3, 7, -1, 3, 3. Okay, there we go. Okay, there we go. Okay, I was just getting annoyed with the min heap. Okay, that's so annoying to have 3 penalties. Like, okay, I was just trying to get fancy with a min heap, and just, you know, deleting until we have k elements, and there we go, and so on. But it's just like I was now getting the last cases. Just sorting it and returning the kth largest works. So that's annoying. Okay, Alice and Bob are playing a fantasy. So now it's like I really have 50, but minus 15 minutes, which is 35. Yeah, so I'm not solving both. I trolled so hard. Okay, Alice and Bob are playing a fantasy battle game. Okay, if I can solve at least one of the hearts, that makes up for it. It's just that's a shame. Like I know I don't get a penalty on time limit exceeded. So why am I trying to get fancy with a heap? Why am I trying to get fancy with a hide function when I just care about getting a correct solution? And then if I TLE, then I start, you know, trying to make it faster, because TLEs do not count as penalties. Wrong answers count as penalties. So that's just the lesson for next time. Just write the correct solution first. Don't try to be like the cool guy and make things efficient, right? Just make things efficient once you TLE, especially in a contest. Okay, Alice and Bob are playing a fantasy battle game consisting of n rounds where each of them summon 3 magical features: a fire dragon, a water serpent, or an earth golem, right? Okay, FWE. In each round, a player simultaneously summon their creature and is this like rock, paper, scissors? If one player summons a fire dragon, one summons player summon a fire dragon. Okay, this is literally just rock, paper, scissors, right? So F, W, E, right? So here F is better than E. Water defeats the fire. Yeah, earth defeats water, right? Okay, so this makes sense. It's like Pokemon. Fire defeats earth. Okay, so it's like fire is equal to paper or scissors. Then E makes it paper. And then W is equal to rock. Right? Because rock defeats scissors. Scissors defeats paper. And paper defeats rock, right? Okay, cool. So this is rock, paper, scissors. Okay, yeah, this is legit rock, paper, scissors. Okay, you're given a string S consisting of n characters. Of course. FWE representing the sequence of creatures Alice will summon each round. Okay, cool. Bob's sequence of moves is unknown. Of course it is. But it is guaranteed that Bob will never summon the same creature in 2 consecutive rounds. Bob beats Alice if the total number of points awarded to Bob after n rounds is strictly greater. Return the number of distinct sequences Bob can use to beat Alex. Jeez. Okay. So, number of times that he needs to beat Alice, right? So what's 3? 3 divided by 2 is 1. Well, here he needs to win 2, right? If it was 4, yeah, so num to win is equal to length of S over 2. We're going to put that in parentheses and plus 1, right? That's the number of times Bob needs to win at minimum in order to win the whole thing. So essentially, it's in given S slots, how many times can I fill num to win slots? Is this literally just a permutation problem? How is this LeetCode hard? So here, it's like, oh, but I don't know the library for permutations. Oh, bro, please. I don't know my combinatorics. Import permutations. Okay, here we'll do import permutations, return 1, right? I want to see combinatorics. Okay, I'm gonna have to remember that formula. Oh my goodness. Okay, so for something like this, it's 3, right? So he needs to win at least 2. So it's 3 choose 2. What's 3 choose 2? Is 3 choose 2? Bro, I don't remember the formula. It's been too long since high school or college. Is it something like n factorial divided by n minus k factorial? Something like this? So it's like here it would be 3 factorial over 3 minus 2 factorial is equal to 6 divided by 1. Does work. Or however many ones it's away, right? So here it's 1, 2, 3, 4, 5. Or maybe it's times k factorial, right? Something like this. So over 1 times 2 factorial, which is equal to 3, right? And for something it's like 1, 2, 3, 4, 5. Jeez, dude. Yeah. Okay. It's factorial. I need that life. It's not cheating if I look that up. Like, surely. It's just, I know what I need to do. I just need the combinatorics formula. 1, 2, 3, 4, 5. And then here it's like, he needs to win 3 times, right? So 5 choose 3. So if I do 5 factorial divided by 5 minus 3 factorial and 3 factorial. 5 factorial is 120 divided by 2 factorial. So this will be 2 times 6. So this will be 120 divided by 12, which is equal to 10. So this is not the way. Or maybe it's permutations, not combinations. But that's like, what the hell? Like, 120 over x gives me 18. What the hell is 120 over 18? It's not even a round number. 5 over 2. Oh, no. Oh, it's a choose. Right, it's times 2. Because for each one he can pick 2. Oh. And for the rest, okay. So he needs, so for num, okay, there's length of s. Okay, I know what's going on. Right? There are length of s total slots. For num to win many of them, he must win, which gives him 2 options to do so. I.e., actually 1 option to do so, right? There's only 1 winner in those ones, right? For the rest, he can either tie or lose, which gives him 2 options. So answer is num to win, choose 1 plus length of s minus num to win, choose 2. Okay, so def combinations self and choose k, and comma k, right? Oh, factorials, bro. I need the library to do this efficiently, bro. Like, it's not cheating if I look that up. Surely. So it's like, oh my goodness. I need those combinatorial formulas. Like, if I look up combinatorics in Python, surely that's not cheating. Like, surely. And here I have to think, like, at 15 minutes I'm gone. 5. I have 25 minutes. For now I can just do definite self.factorial is equal to this. Def factorial self comma n in self.factorials turn self.factorials of n. Res is equal to n times self.factorial of n minus 1. Factorial of 0 is equal to 1. Factorials of res is equal to n. Of n is equal to res. What am I saying? In res. Numerator is equal to factorial of n. Denominator is equal to factorial of n minus k times factorial of k. Turn numerator divided by denominator. I hope that's right. I forgot my formulas. I forgot my stuff. It's like being a stat student. Okay. Okay, this choose 1, right? There's only num to win options, right? Then this choose 2. So for each of them, it's like okay, maybe it's actually not that difficult, right? I have 2 options, either I lose or draw. right? Because he has to win specifically that many, right? A draw doesn't, it counts as 0. And a win doesn't, a loss doesn't, can used to be. Oh, wait. Is it not one, how do the point system works? Bob can never summon the same creature in 2 seconds. Oh my goodness, so it's not that simple. Bob beats out if the total number of points awarded to Bob after n rounds is strictly greater. Okay, and how are points? Am I thinking of this right? Oh yeah, it's whoever the winner is awarded a point. Oh, after n rounds, right? Oh my goodness. Okay, so it's not as simple as the combinatorial stuff. It's an actual LeetCode hard. Okay, and then this. I'm gonna get 2 out of 4 again. I wish I didn't get penaltied. Oh goodness. Yeah, because for this, it's like I kind of know what to do. It's just gonna be annoying. It's like factorial logic, modulo some results, and then it's like, okay, you can never make the same move twice. So it's like it becomes 1, 2, 1, 2. It's like a wave, and it's a counting problem. He just needs more Manzanares, right? Yeah, okay, this is too much. This is too much. This is too much. Yeah, it's 1,000 cent. Yeah. So you can square, but like, it's too many details that I know I like, especially because it's minus 15 minutes, right? I have 20 minutes. It's too many details for me to get this in 20 minutes. So it's just, that's hopeless. Like, the solution is probably nice and elegant, but it's too many details for me to think about to actually get to the solution, right? It's like not two consecutive. It has to be more points, so it could be that, like, they tied and so on. That's too much. That's too much. Okay, so now at least we can try to solve this problem, the most well-worded problem on Earth. You're given an array nums of n integers and 2 integers k and x. The x sum is yeah. Oh my goodness. Okay, so we can think about how we're gonna do things more elegantly, right? So here we can do def. So yeah, first of all, we can do a sliding window idea, right? So that we know the dictionary every single time. Right, so we can already at least do that. So at first, we're gonna populate the first k elements, right? Yeah, so this is it. D. Answer.append. Self.find x sum helper. We're going to give a dictionary D now, and an x. Right? So here it'll take a D. Right? And the point is that here from this point on, I'll do Okay, this is initially at 0. Yeah, this is bad. I to I plus k, right? So this contains 0 to k. 0 to k minus 1. Why is this k plus 1? So, oh my goodness. Okay. I to I plus k, right? So for the next iteration, we need to remove I. And then we need to add I plus k minus 1. So why is this wrong? It's clearly wrong. Print each time. Maybe something like this. No, that doesn't help. Man, why? So yeah, at the beginning it's 1 twice, 2 twice, 3 once, 4 once. Then yeah, I get rid of a 1. I should add a 2. Yep. Yeah, so it's too slow. Tell them to exceed it. Okay. Yep, so sliding window doesn't work, and it's because this is too slow, right? So maybe I should have the min heaps. Also, yeah, some idea of like the k largest at any single point in time. Um, yep. So maybe I leverage some idea where it's like I keep the min heap essentially all in one spot. What if I have stale data? But does it matter? Hi. Yeah, this contest is an L. Again, rip. Min heap. For num in D, heap q dot heap push. Yeah, so pushing the value and then num. And then this value will might not be correct if I didn't pop it. Maybe I keep more metadata. I keep like an index I. And that way it's like if anything is not my current index, don't want it. Okay, maybe we do something like that. Comma 0. Right, so it's like I keep track of a current index. And if it's not my current index, then I don't care about it. Alright, some idea like that. I'm so close to it. There's gonna be some idea like that. It doesn't work that way. Or maybe the third value, if I do it based on the index. No. Because for decreasing frequencies, it doesn't work this way. That's annoying. Oh, that is annoying. Good sort nums. I want the k most frequent, x most frequent elements. So maybe in my heap, I keep track. Maybe I keep track of a dictionary with all the updated values, right? And so whenever I pop something from the heap and I notice, oh, it doesn't match with the actual value, I will unconsider that, put that back into the heap with the correct value, and then get the next, right? So some idea like that. Okay. Yeah. Let's do that. Right. We'll add to our answer something like that, right? Loop invariant. This crap, right? And then here's like return ends. Okay, we're gonna cook. We're gonna cook. We have 8 minutes left. Right? That is equal to val comma num is equal to that, right? If num d of num doesn't equal val, heap q dot keep push d of num comma num. Oh gosh. Do I have a return somewhere? What the heck? If I comment this all out, it still works, right? And what the heck? Oh, first of all, this should be min heap. D of num, it doesn't equal val, bro. And I only have 5 minutes left. I was pretty sure like this is it. Bro. The point is I should only have valid stuff in there. This is frustrating. while the length of the min heap is greater than x, I get the val and then the num. Right, and then here, while min heap of 0, min heap is greater than 0, and min heap of 0, 0 doesn't equal min heap of 0. How do I get around this? Madness. This is ludicrous. Yeah, okay, I have a minute left. I'm done. I'm cooked. There's some idea. It's just like, essentially, I have the dictionary. I have the dictionary as like, you know, my holy grail of like accurate data. And actually, here what I'll do. I'll heap push. Main heap. D of num, comma num, of I. Nums of I. Heap q dot heap push into the min heap. D of nums of I plus k and num. All of a sudden we're getting a different story now. We're getting different stories now. Okay. We'll have these both at the beginning and the end. Six, 16, 14. it defeats the point of the heap if I check that, like, you know, any element is invalid. The point is that, like, in the main heap, this guy will get popped first, right? So that's good. But this guy, this guy's not so good. Hey there, sorry about that. My recording stopped because I ran out of disk space on my machine and so on, so I had to clear up a couple of old videos and so on just to make space to continue the recording, so I apologize for that. But yeah, okay, we're at 10 minutes left. With the penalties, that means it's already over. For this, I was trying to think of a way. Man, this is a frustrating one. Like for Q2, I just screwed myself with the penalties. But even here, right, like, it's like the only thing we gotta consider is like, okay, this guy could have been the only possible changed candidate, right? So that's like we loop through nums. Again, it's like I like the idea of a min heap where it's like I need to correctly coordinate my hash map with the actual truth with the min heap that doesn't have the truth. Yeah, because if I clear everything in the min heap and I add everything back, it's like I gain no advantage complexity-wise. So it's like there's got to be a way to deal with the bad data. I'm trying to think, but I can't really put two and two together here. I take an L in this contest, not gonna lie. I kind of take the L. Again. Okay. I think my mistake is just that, like, I got 3 wrong answers on Q2 because I was trying to make it efficient instead of correct. And that ended up frustrating me a lot, such that, like, I didn't start thinking hard on these problems. It's a bummer. Big bummer. Yeah. Yeah, not much to do here. The contest is still going on for another 8 minutes. I mean, I guess we can keep trying to solve it while we have the 8 minutes, right? Even though we have 3 penalties, we can see if we can get it right. But yeah, in 8 minutes, I'm probably not going to do much. The problem is that I might get incorrect data into my min heap, which only ever happens here. This is the very first time that I add this guy, right? Heap. There. Now I've taken care of it, right? And this is a new value that I've never added before. So now I don't need this crap. Nor do I need this crap. Right, I don't need this crap. How is nums of I9 in the heap? Bro, what? Literally, how is nums of I... What? Heap queue to heap push, D of num and num. Then I have at least the very first K in there, right? Heap pop. Found I equals false. Equals nums of I. Found I equals true. If not, found I. Okay, I don't even know. I don't even know what to say. Nums of I has to be in there. What are you talking about? Bro. How big is K? K is 6 or K is 2? Like, you've got to be kidding me. Found of I. This just whatever. Oh my gosh. I don't even know what to say. Literally, if I haven't found nums of I in there. Well, print D, nums of I. And every other print comes a hashtag print, except this one. Found of I. 3 is in there, bro. 3 is in there, all right? 8 is in there. Now 7. Why the hell is 7 not in there? Also, where am I getting 7 from? Oh, from here. Okay, but like here at nums of I master equal 1, and I heap push it, right? Like, and here I heap push it. Okay, I take the L on this one. I will call my friend Nor in 1 second, so just give me 1 second, and I'll be right back.
I was so close to greatness, like I could feel it in my hands, and it was taken away from me.
I see.
Well, how did we do? 2 out of 4, 3 out of 4?
2.
Oh, I see. Which one did you get stuck on?
Q4.
Oh wait, which ones did you solve?
Q1 and Q2.
Oh, I see. Look, bro, Q4, like, it was just implementation heavy, I think. But no, like, okay, I came up with a really good structure. Like, I remember a daily, like, a month ago or maybe 2 weeks ago.
All one data
where
structure?
There was, like, this...
All one
like,
data
this
structure?
linked list structure.
All one data structure? Like, this name?
What?
This one?
I don't remember. Is that... Oh, maybe that's what it's called. Yeah, I was doing, like, sort of data structure.
That is exactly what was on my mind.
Close. Dude, because I realized, like, 10 minutes left in the contest that my thing... Like, I was doing sliding window, but I was still recomputing the thing in the window. But if I just realized earlier that, like, the sliding window needs to include, like, instead of recomputing the total sum in that window, I just need to shift properly. Like, I could have done it. I just needed more time.
Oh, I didn't even get to that part yet. I couldn't build the thing correctly with the... I was using a min heap.
Oh, no, I built it. I'll show you. Like, I built for Q4, and I got it working, but then it TLE'd because I didn't make it smart. But making it smart is not that hard, actually. Like, I'm so close to making it. Dude, I got TLE with 1 minute left. Like, look at this bitch ass. You see this? I got TLE with 1 minute left, and it's like, I need 10 minutes to make this faster. And I can't. Dude, it was so sad. I was, like, praying that it goes through. Because I realized as I was submitting it that it's not going to be fast. Wait, did you just not do question 3 at all?
No, was that permutation, combination, stat stuff?
It was just DP.
Oh, was it?
Yeah. I mean, it feels like permutation and all, but it's just DP. I'll show you. It was actually a lot shorter.
No way.
Here, you see my Q3?
I skipped it because it was like, it's too many details.
Well, yeah, but that's how you know it's dual. Here's my Q3. And for reference, here's the one you tried to do. Here's my Q4, which TLEs, but is correct almost. You see my Q4?
Yeah.
Here is my Q4, and it's 103 lines and not done yet. Here is Q3 that you skipped, 31 lines.
Wait, what did you do?
it's DP, right? At every point you have 3 options. Like look at the constraints. It's only 1,000.
I thought
At
of
every
I thought
point
of DP at some point in my head, but then I was like, no.
no, but you either like
Actually, wait, that
at
makes
each
sense.
point.
Is you just do you have the total number of points that Bob has over Alice, and it's like, you know what you need left.
Like here's all I store. Here's how many points you have, your last action, and your current index. There's 1,000. So your number of points is at like between like that's like let's say that's 1,000 different things you could be, and this is 1,000 different things. And last action, there's only 3 actions. So you're looking at 1,000 times 1,000 times 3. That's times like 3 of this. You see what I'm saying? Times 3 again, I guess here.
I see.
Like each point is just hey, but like I'm pretty much saying here is your turn, Bob. Make a move, and Bob is like, okay, I can either do water or earth or fire, and at each one he's counting how many ways he wins.
Right.
So he's
I'm
like,
so dumb.
so he just shifts it over. It's very standard DP actually. It's just like reading DP. You know what I mean? Like we gotta understand.
Dude, I thought the problem was like
You know,
statistician permutation, so I was like, I'm not doing it.
yeah, that's what I thought too at first. But dude, like this being 3 points is low-key criminal. This might be the hardest easy I've ever had. Like, it wasn't hard at the end. Bro, look how much fucking shit is in this shit. Did you find a fast way to do it? Like, look at my thing.
No, I was also spending time. I was like, bro, I need to get out of this easy.
Dude, like, easies usually take 5 minutes. This took me like 15 or 20 or maybe more. Because I ended up, for each index, I just had frequencies. And then I sorted the frequencies. And then I picked the top and added it.
You did Q2?
Huh? Yeah, I got 3 out of 4. Dude, I'm telling you, I almost got 4 out of 4. I was so close. Anyways, we cannot.
Oh, what is the answer that says there?
The what?
Let me put you on
an
a.
answer?
Oh, someone else was putting an answer. Otherwise, here I put you in the pop out
you
window.
Want this guy's answer?
Yeah, I want to go see that. Let's go out of the contest. I'll screenshot this
Let me see.
for later.
I mean, I still did well. Like 3 out of 4 ranked. Like they made the questions harder, so there's not as much cheaters. So it's like actually a decent rank.
What's the where? Oh, contest. Where's the discussion? My contests. I had three penalties. I couldn't solve Q2.
Q2. Oh. Perfect. Dude, I couldn't fucking read Q2. I kept, like, clicking run and getting a different answer. I'm like, why is this wrong? And then I'm like, wait, that's not what the question is asking. It's kind of elegant, though. Do you see my solution?
Show me.
My Q2 solution here.
All you do. Got the bell. Oh, you did sorted. Disgusting. No min heap. By the way, I got 3 penalties because I was trying to be cheeky with min heaps. I was like, bro, okay, I'm just gonna do a sorted. If I TLE whatever, I'll do min heap it. So and then I did sorted and get the K-1 element. I was like, haha, accepted. I was like, are you serious?
I mean, you can have about 2,000 things in here. So sorting 2,000 is not that big of a deal.
Okay, fine, but like, it's just rip. Like, okay, for the next contest, like, my biggest mistake was literally in Q2. Like, I know that you don't get penalties for TLEing, so it's like, just do the slowest but correct solution and then optimize it as you need. Don't try to optimize it like a cheeky guy.
You get a minus either way.
No, at TLE you don't. Q4, were you getting penalties for TLEing? No, you weren't.
It's not correct. If you
Yeah,
If you get wrong answer or TLE before it's correct, it doesn't matter. But
you-
once it's correct, they add up.
No, if you get a wrong answer, it's a penalty. If you get a TLE, it's fine.
There's no way that's true, bro. There's no way.
What do you mean? It's a correct answer, but you TLE. So just try again to get a good solution, but no penalty. Penalty is when you submit a wrong answer.
Okay, hold on. Each wrong submission did like. I mean, it doesn't matter. There's no way that's true though.
Well, it is true because I've learned this.
Okay. On a question that you got correct, it was a previous submission that was TLE, and that one did not give you a penalty.
Yeah, I've TLE'd many times. I've never had penalties for those. I've gotten wrong answers, and those I get penalties for.
You don't get penalized unless you get the question. If you get the question, you get penalized for every wrong answer you had. It's just that you probably, if you TLE'd, you probably just didn't solve the question after in time.
I don't know.
I mean, that would be kind of busted. I don't know. Like,
Okay,
that's kind of
okay.
weird.
Build the
Like,
frequency
TLE
map
also
over
means
each
you
case
did the
size
wrong
window.
conclusion.
Get the frec value because. Oh yeah. DFS returning. Okay. Q3 DP index Bob score last move from Bob. Why is the last move important for the DP part? Oh, so that you don't have two adjace. Dude, that's so.
Yeah.
Why didn't I think of it? Like, oh my gosh, I don't know why. I was like, it's not DP. It must be permutations counting, and I know that there's too many details I won't be able to. I don't know. Like, I legit could have gotten Q3 so well and got my first 3 out of 4. Let's see.
Yeah.
Keep a sorted list of
I mean,
frec
like,
V pairs of the current window and track the sum. As you move the window, adding numZine, removing IMA escape, perform 4 operations. Removing. I see. LeetCode doesn't want us to be happy on LeetCode.
Like, I set up a whole data structure to make this smooth, like the frequency count, like with linked lists, and it works. I just have to have that O of 1 operation instead of O of n operation, which is very doable because I already do it. Like,
Is Q3
like,
always
I
easier than
insert and remove
Q4?
in O of 1. What?
Is Q3 always easier than Q4? Should I just start targeting to do Q3
It
from
should.
now on?
I mean, dude, it should be. Like, it's rare for Q4 to be easy.
I don't know. Like, I've been in,
like you'll see the point count.
I've been in 2 contests where they say like, oh, Q4 was easier than Q3. And it's like, okay, I'll stop doing Q3.
Or just read them both and choose.
I mean, that's what I do, but I chose Q4 because I thought Q3 was like permutations galore.
I don't know.
Like, if Q3 was given to me as a medium, I would have been like, okay, let's think about it. But because it was a hard, I assumed like, oh, okay, there's probably gonna be some hard thing. Just sadness moment.
Oh well. Oh my god, I mean, I guess it's fine. I got 3 out of 4 quickly. If I get 4 out of 4, I would have got a record for my placement.
That's a rip. You do a lot better on these than me. It's kind of impressive.
I mean, I don't know. You distract yourself. Like, all you had to do was focus on Q3 instead of Q4. I feel like you would have got Q3. How much time did you have?
Not much.
Like, when you got 2 out of 4, how much time did you have?
I think like an hour, about 3 penalties.
Well, the penalties don't. Like, that just affects your total time. You still have an hour.
Wait, what?
But, like, the penalties are at the end. If you go to the end, there's people with, like, a fucking 3-hour finish time on a 90-minute contest because it just gets added to their time. You still have the whole 90 minutes to solve.
So if I have 100 million penalties and I solve Q3, I still get the submission solution?
Yeah, you would. If somebody gets 2 out of 4 if someone gets 2 out of 4 in 1 minute, and you get 3 out of 4 in a million penalties,
there's no way.
I
I gave up thinking at 15 minutes because I was like, okay, my time is over.
I see.
What?
That would be kind of dumb. Like, no, It's a way to balance out the rankings, right? It's a 90-minute contest.
Oh.
Just to,
I thought I was like, okay, it's just like my time is over, so just stop thinking. Try some things if you
wait,
want to.
click on the rank, sir. Go find out what your rank was
I don't
in the
know,
page. Just go click on ranking. Click more.
bro. I don't know what you want me to do.
Bro, it's not that complicated. You
It's
scroll down to the bottom of the contest page. There's a ranking. You click more, and it tells you your rank.
global ranking.
Um, I guess so. Like, there's 29,000 people. What is your rank out of 29,000, sir?
Oh, I don't know.
Like, a toddler would get this quicker, bro. I'm asking a simple question. It takes you 2 seconds to go to this page.
419.
You're not 419. That's 3 out of 4.
Oh, that's the contest number.
Oh, yes, that is the contest number.
It says I'm rank. Uh, my thing is golden. The only other golden ranks are 1, 2, and 3. But I'm not.
Okay, yeah, go. It's highlighting you. What is your rank, bro? What does it say? That little left column on the rank.
It says you. Oh, score is 8.
Just share screen, like, dude, like, I was gonna try and make you feel better about
Six.
2 out of 4,
It's
but never mind.
6689.
6, 6, 8, 9. I mean, that's not bad.
I don't know.
That's like 9th category, you know. So you'll go up in rating.
It's just I'm so mad that like I was doing heap, like trying to do implement fancy heap, and it's just like kept getting penalties for it. I was like, let's just try a sorted list and just there we go, and it's like insta works. Just
Yeah.
like okay, in these so TLEs do count as wrong.
I think so. I mean, it would be busted if they don't. Like a TLE solution, just a bad
For each
algorithm.
wrong submission, like wrong answer submission.
Hey, feel free to experiment. Add like a for I in range 1 million, print, submit, TLE, then submit again.
On like the
correct
next
one.
easy of the next. Honestly, it might be worth experimenting.
Or just like do your best to not TLE.
No, but I need to know, like, because then
Okay.
then you can put slow but correct solutions, and then it's like only fix them as you need.
Up to you, bro. I mean, like, listen, it's better to get 3 out of 4 with like 7 million penalties than 2 out of 4. So either way, it's always better to solve. You're not at a point where you should care that much about time yet. Time is for
Okay,
like
I don't.
breaking.
Yeah. Now that I know that how that system works, then yeah, I thought the way penalties work is like, like if you have 3 penalties and your timer's at 15 minutes, it's like you're cooked, you're done. There's no mass acceptable solution to accept. I guess I'm
Yes.
kind of stupid.
Yeah, a little bit.
Okay, in my defense, is because I've never gotten to a point where I had a penalty and I solved another problem.
Let's see. I mean, to be fair, this is a contest where I understand people getting 0 out of 4 because, like, even Q1, like, it's kind of easy, but kind of not at the same time.
I'll send you this video once I'm done. Just like it's just like 15 minutes of me going like, what is the problem saying? What I don't understand. I'm like, what's going on, dude? Like number one solving Q1 and wait, it took second place 90 minutes to solve Q1. What?
They probably just skipped it. Like, they,
Oh, 13 minutes for Q3. What the heck?
like, they don't do it in order. Like, the top people, they look like they do all of them at once and then they submit them together. Or, like, they do
Why?
if they know they can do it. Like, yeah, look at top guy. No, the top guy did Q1 in 1.5 minutes, Q2 in 2 more minutes, Q3 in 5 more minutes, and Q4 in 4 more minutes.
Dude, how are you that cracked at like LeetCode? Like, how do you do that?
That he actually has a distance. Like, he finished in 12 minutes. The second guy finished in 20 minutes. Like, that's like half time.
Chinu. What?
Let's look at this guy's profile.
87 solved?
Oh, this might be a cheater. Because look at this guy's profile, bro. He just got number 1, and his history is like 1 out of 4.
Oh, you think it's a cheater? Oh,
Let's
damn.
find out. Yeah, it's a cheater. Click on the.
Holy
click on
crap.
his
Okay, number 2
solutions.
is
You
not
can-
a cheater. Number 2 is Giga Chad. Well, actually, yeah. What? Wait, the global ranking is weird, but the number of problems solved is insane.
Which one?
Number 2.
Number.
Wait,
two.
this is
I don't,
weird.
I don't understand this, bro. Like, fucking 1 out of. If you get 1 out of 4, you cannot legally get 4 out of 4 right after. And then get number 2 right after. Like.
Well, they've gotten 3 out of 4 before. 4 out of 4.
Okay.
Wait, he
no,
solved
like,
he solved 1,000 LeetCode problems though.
No, that guy's cheating. Okay, here, you want free points? Report that guy. Look at his solution for Q1. Like, that's not.
What?
That's not
You can see
normal.
his solutions?
Yeah. All solutions are public on contest.
How do I
You just
see
click
him?
On their little,
Oh.
like on the contest page, you see how there's like a time. Click on it. It'll show you his code. Like, I guarantee you, bro, that's not. That's not like.
What? What? Report cheating. Well, yeah.
Yeah, you get free points if you're one of the first
L-
10 people to report something.
LMAO. Oh, I can't submit it. He is definitely cheating. Or if you're the first 10 people? Okay, I'm not gonna be first 10 people. Bro. What are these things? 4S, 4N, Ford?
Like, they're just like you're copying some shit from out of nowhere, and it's like just.
What is he even
Like,
copying?
no one is typing that shit, dude. Like.
Maybe he has it pre-copy pasted though.
Like, he defines for IAB to go fast. He just. Maybe I reported him too quickly. Hold on. But okay, dude, like, these people's profiles don't add up. How can you be, like, solving 4 questions in 20 minutes and, like, your previous contest is, like, rank 1.5?
But what
and
am I
the one
seeing?
before that is 1 out of 4.
But what is he even cheating from? This is like not like ChatGPT or anything.
Yeah, that's true.
ChatGPT
It's
would not
also-
write code like this.
Also, this guy, maybe he's just been grinding because you, like, his.
What about number
score was
1?
in December.
Number 1? Bro, okay, no, that's how I know. Look at number 1's submission 4. Oh, no. I clicked.
Nah. No, that's normal though. We need different structures.
No. Oh, no, I clicked on the other guy's question 4 by accident. Wait. Q3 by number 1. It just looks so funny. What is Lufren Ikshak? Is that his name? Did I butcher
What do
that?
you look at?
Question 3 of the number 1. Jeez. I could have solved Q3. I'm a little salty. Why didn't I think DP for Q3? That's so
I mean, you gotta just spend more time on it, right? Like, you have
Yeah.
to, yeah. Like, Q3 is supposed to be easier than Q4.
I told myself like, oh, it's permutations hell, and I won't get it. Okay. For those watching this video, I guess that's pretty much it for this contest. Question 1 was just a just do it question, so that one was straightforward. Even though the question was not too straightforward and confusing and zigzaggy, it's like once you read it in full and understood it, you were able to do it. For question 2, essentially what we did is I was able to just traverse through the entire tree, just a typical traversal, and then I just used this check as a condition to know if a node is essentially perfect or not, right? A node is perfect essentially if both of its children are perfect, where none, like i.e. the root, like all leaves are perfect, right? So it's a leaf has both the left and right child as none, so I set none to be perfect, that way it works out. So if none is a perfect child, then I essentially say, okay, if both children of a node are perfect, and it is the case that it's the height of both children are the same, then that node is also perfect, right? So like one, both children are perfect because none is perfect, and both of its left and right child have a height of 0 because none is 0. I initially defined these into a hash map over here. So essentially these are perfect, right? So essentially every leaf is perfect, and then like for something like 5, it's like, okay, both of its children are perfect, right? Because again, we recursively solve this and so on, so that we've already solved we do this in a post order or type of search, where it's like here, if I do populate, we do the populate of root.left and populate root.right first, so that when we get to a root, we've already done both subtrees and so on, so we can use the results, right? So it's a post order search of population. So that way it's like for something like 5, I look at the left element, it's like, oh yeah, it is already perfect, and this one is already perfect. And what's this guy's height? This guy has a height of 1, this has a height of 1, therefore this one is a perfect node as well, right? And then when I look at something like 2, this is a leaf, so it's perfect. Then for something like 3, it's like, okay, its left is perfect, its right is perfect, but this has a height of 1 and this has a height of 2. So this one is not perfect, right? And I do that for every node. And then essentially at the very end, it's like, okay, let's grab all the nodes that were marked as perfect. Let's get, we know their heights, right? And we know how to compute the number of nodes based on the height, right? So it's like height of 1 is 1 node, height of 2 is equal to 1 plus 2 nodes, i.e. 3. Then it's like a height of 3 is equal to 7 nodes, a height of 4 is equal to 15 nodes, etc., etc., etc. So it's like you essentially get all the perfect nodes, get their node count, right, per tree, right, where it's like if it has a height of x, get its node count, and then take all those values, sort them, and return the kth largest if it exists, or -1 if it doesn't, right? And that's essentially how you solve that problem. For question 3, it was essentially dynamic programming. I thought it was going to be some permutations madness, so that's why I skipped it, but now I feel a little sad because like this is my favorite type of problem to solve with DP, so just feel a little sad. Should I take the time to solve? Actually, no. I know your solution with the previous move and so on now, so it's like kind of cheating, but yeah, this would have been a fun one to do if I realized it was DP, so that's a bummer. And then for question 4, I just got stuck on trying to make things efficient, right? We were TLEing. I was trying to get trying to use the sliding window. I had 3 things that were linear when they needed to be constant time, so I was trying to leverage a sliding window technique to make it all efficient, but I wasn't able to do it in time. So main takeaways from this contest is number 1, I need to realize that the penalties don't affect the time. So it's like if I had 15 minutes left, I still have legitimately 15 minutes left. The penalties do not actually mean that I don't have it. So I can still actually solve the problem and not worry about that, which I didn't know, and so that will be very useful for the future contest. I won't be discouraged by penalties. And another one is I need to test if time limit exceeds counts as a penalty, or even if it doesn't. If it doesn't, I need to start focusing on just implementing a correct solution for questions instead of trying to implement efficient solutions, right? And then if I TLE, only then do I try to optimize it and so on. If one of you guys know whether a time limit exceeded counts as a penalty or not, I would highly, highly appreciate if you left me know down in the comment section below. That way I can kind of use that idea in the next contest, where it's like, oh, if it does affect, then okay, I'll try to build efficient solutions from the get-go. If it doesn't affect, then I'll purposely write solutions that are correct but slow, and if they TLE, make sure that I implement them a bit more optimally. But otherwise, it's pretty much it for this contest. We were only able to solve 2 out of 4 again. I really, really look forward to the day where I'm able to solve 3 out of 4, and then one day 4 out of 4, so we'll see. Just still grinding, still the 2 out of 4 stuck phase, but we'll break out of it hopefully soon. So that's pretty much it for the video. If you did find it useful or enjoyable, I would highly appreciate if you left a like or a comment. But otherwise, I'll catch you next week. So until then, ciao, ciao, my friend.